Alright, so let's take a look at 9.2 graphing polar equations. Pretty simple objective here. All I want you guys to be able to do is just input a polar equation into your graphing calculator, generate your table of values, plot the points to create these very artistic looking mathematical graphs. And just a reminder, when we looked at our polar graphs, we looked at several different classical curves here. One of them is the rose, illustrated by this equation here. Next up was the limacone. And those equations there create that little loop in the middle of your graph. The lemniscate. And we talked about these functions, and the trick to being able to type these functions into a graphing calculator was being able to know how to handle when you have an r squared like that. So for example, suppose we had an equation for a lemniscate that was r squared equals 4 cosine 2 theta. To properly type this one in here, we'd have to take the square root on both sides. So our calculator would be typing in the square root of 4 cosine 2 theta. Next up, the cardioid, heart-shaped graph. Very similar to the limacone. The only difference is that the two values that you use in your trig function are actually the same value here. That's the way you're going to create that cardioid. Remember, with the limacone, we actually had two different values here. And then finally, the spiral of Archimedes. We create that spiral with not using any trig, but actually just taking r and saying it's equal to theta, and we can use any scalar we want there of a. The only reason why they say that a theta should be radians is it makes it a little bit easier to graph. Speaking of graphs, make sure that when you are graphing these functions here, when you first start these ones out, go ahead and put that mode of yours in degree and make sure polar is selected. And then when you look at your graph, before you start graphing anything, hit the zoom button, put in standard viewing window, and then hit the zoom button and square it up as well. So let's make some graphs. Okay, so for this very, very basic graph, just says r equals sine theta. Let's go ahead and type it in. Probably got to zoom in on that a little bit, shouldn't we? There we go, a nice looking circle there. So what do we do next with this? Let's go to the table of values. That's what you want to do next to get your points made here. Make that graph, that table of yours start at 0, and if your table here is not counting by 15s yet, you're going to want to do that. Trick to doing that is you can either, with the update OS, notice right down here, you can press the plus sign, and you can change what those tables are counting, what those values are counting by, or if you hit second window to go to your table setup, you can do either one of those routes. Okay, so now we have those points, and we just go ahead and we plot them. One thing that you're going to want to establish is, when you look at these here, is notice that the maximum this graph reaches is 1. So when you make your graph do its thing, make sure you plan accordingly before you start graphing. I'll make that be 1, which would make 1, 2, 3, 4, 5, this part right here, 5/10. So let's start plotting. And now when you get here, there's going to come a point where if you know what shape's going to happen here, you can kind of let symmetry take over. Note that we can create another point at 120 degrees, the same spot that was at 60 degrees. We can create a similar point here at 45 that we're going to make here at 135. And the same can be said here at 30 degrees along with its partner over there at 150. So let's go ahead and fill those points in using a little bit of symmetry. So there we go. We have a nice looking circle there. Alright, let's do another one. First step, type it in. Get the graph. Go to the table. Travel for a little bit to see how far it goes. Looks like if you are paying attention here, right out there is about 45 degrees. It's about as big as it gets. So when you look at your table here, we need to make this puppy go all the way out to about 3. So let's do that on our graph. Just made every other mark count by 1, so that means each mark there is a half. So let's plot these points. Now when we make the first leaf here in the first quadrant, once we get that far, why don't we just let symmetry take over? So now once we have these, realize where all these points are going to go. They're going to be in the same quadrants everywhere else. So let's plot those as well. Alright, so there we go. Now it's just time to draw on the graph. Alright, good deal. So we're starting to get the hang of these here.